The first rule is about significant figure. The first rule is all non-zero numbers are significant, right? So let's suppose if I'm giving you an example. An example is 1, 2, 3, 4. So in this case, in this question, 1, 2, 3, 4, all are non-zero. That means in this case we have four significant figures, right? Let's go to the second rule, and second rule is zero between two non-zero digits are significant, right? So what question is saying? Zero between two non-zero digits. So if I'm writing 3402, right? So 3402, according to the first rule, 3, 4, and 2 are non-zero in this case. That means we have already three significant figures. But according to what second rule is saying? It is saying zeros between two non-zero digit are significant. So 0 from the left side of 0, that is 4. From the right side of 0, that is 2. So in this case, we have four significant figures, right? So let's move to the third rule, and third rule is leading zeros are not significant. I'm repeating again, leading zeros are not significant. That means 1, 2, 0, 0, 0, 0, 0, right? So after 1 is non-zero, that's why it will be counted as a significant figure. 2 again is significant figure, but leading zero, that means 0, 0, 0, 0, 0 is not. These things, these five zeros are not your significant figures, will not be counted. That means in this case only two significant numbers are there, right? Correct. So let's move to the rule number 4, that is trailing zeros to the right of the decimal are significant. So what I'm repeating again, trailing zeros to the right of the decimal are significant, right? So let's try to understand this from an example. Let's suppose 92.00, right? So in this question, this is a question, and in this question we need to find the value of significant figure, number of significant figures in this question. So if the question would be 9200, in this case we knew the answer, and answer is only two significant figures because these are trailing zeros, and these two trailing zeros won't be counted, right? But in this case we have a, what we have a point, right? So this point will change all the scenario, all the result. Why I'm saying? Because if I'm writing 1 and if I'm writing 1.00, so there is a huge difference between these two are not same, right? How, on the basis of what I am saying, you will say, sir, 1 and 1.00, basically it's same, right? So it is not same according to the concept of error, right? So you can check this out. You can ask this to your faculty directly, what is the difference between 1 and 1.00? Both are not same, right? So in same case, according to the concept of 0, 92.00 have actually four significant figures. If you have trailing 0 and just trailing 0, point is there, then you will have to count those two extra zeros as well, right? So in this case we have four significant figures. Let's talk about rule number 5. So, dear learner, rule number 5 is trailing zeros in a whole number with the decimal shown are significant, right? So, let's try to understand this from an example is, let's suppose we have 92.03, right? So, in this case, uh, 9 is non-zero, 2 is non-zero, 3 is non-zero, right? And after point we have 0. And let's suppose if I'm adding another 0, so all these 5 are will be counted as significant figures. So in this case we have 5 significant figures, right? Let's move towards the point number 6. That point number 6 is trailing zeros in a whole number with no decimal shown are not significant. So I think that's quite simple. So let's suppose if I'm writing 540. So in 540, 5 and 4 are non-zero. So on the basis of the first rule, 5 and 4 are counted as significant figure, but 0 cannot be counted as significant figure. So in this case, we have only two significant figure, right? So basically, let's move to the rule number 7. And rule number 7 is quite easy, because let's suppose if I'm writing 225 into 10 to the power 25. Let's suppose if I'm writing 25 into 10 to the power 25. So according to the step number 1 or rule number 1, we can say 2 and 5 both are significant figure, correct? So in this case we have two significant figures, but 10 to the power 5, that means what I'm doing, 25 into uh 1 2 3 4 25 zeros, right? And we knew we can directly avoid this, so in this case we have only two significant figure, right? So these are the seven fundamental rules of finding the value of significant figures, right? Now let's move to the question. Question is question is 0.000632, and another one is 6.023 into 10 to the power 24 kg. The unit of this is meter square, right? So in this case, what we knew actually, so we knew this zero, right? This 0.0 cannot be counted as significant figure, and this zero again cannot be counted, and this zero again cannot be counted, so these four are eliminated. So what is remain? 6032, because we knew zero between non-zero can be counted as significant figure. So here in this case we have four significant figure. And another one in this question number 2, question number 2 is saying 6.032 into 10 to the power 24 kg. So in this case 10 to the power 24 is eliminated, right? So in this case again we have four significant figure. So answer is 4 for this and 4 for this. So they both have four significant figures, right? Now learner, if you are learning with us and you are really liking it, then share with your friends about us and follow us on our social media platforms. So our social media pages like Instagram, Facebook, YouTube, Twitter, as well as LinkedIn, right? Why I'm saying this, you need to follow us because on our social media pages you will get some amazing content and amazing post, and even you will get some quizzes, right? So go and participate. Thank you.